Hey, Maddie. Let's think about what we're asked here, buddy. We get the tan of 67, right? 67 degrees. So what we're trying to say in terms of its cofunction, if we think about a right triangle, there's two different ways to kind of ask the same question. Let me draw a picture and I'll show you what I mean. Let's say we have oh, that's pretty ugly. Let's say we have a nice right triangle, or as right as I can make it. Okay? And we're given some angle right here. Let's say that's 67. I'm just going to put that in there. And drawing these out is a great way to kind of visualize what's happening. So this is 67. This angle right here, 67. This one is 90. Therefore, this angle up here has to be 23. Right? Let me see if I get my pen working here. This angle right here has to be 23 degrees. Okay, because remember, all interior angles of a triangle have to add up to 180, right? So 67 plus 90, subtract 180 from it, you're going to get your answer there of 23. And if we're to throw in kind of just some values, made up values, let's say this is our A side, this is our B, and this is C, our hypotenuse. Well, the tangent of 67, the tan of 67 equals the opposite over the adjacent, right? So with respect to this angle right here, the opposite is A and the adjacent is B. All right, so that's cool. Now the cofunction of that, how could I use another trig function to basically get the same opposite and the same adjacent side? And the cofunction of tan is the cotangent of, and in this case, we're going to use this angle, 23 degrees. Okay, now the cotangent is A over O, right? It's the inverse. It's the inverse of tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. And if we look, based on that, the cotangent of 23 is going to equal the same deal, right? The opposite of 23 is the B side, and the adjacent of 23 is the A. So we're using two different trig functions, but we're getting the same expressions, right? We're getting the same sides. So in this case, for example, let me just crank it up a little bit, buddy. Throw some numbers at it, or we'll try anyway. Come on, pen. Okay, so if the tan of 67 is opposite over adjacent, that's going to be side A over B. So that would be our answer, A over B. I can make up numbers, but we'll keep it general. So let's prove this now. The cotangent of our other angle, 23 degrees, the cotangent of 23 is going to equal the inverse of that, right? The adjacent over the opposite side. And if we look at that now from with respect to 23, the adjacent side is A and the opposite side is B. Adjacent side is A, opposite side is B. So here we can see we're kind of proving this. It's the same ratio. It's the same setup, A over B. How they're related is if this is some angle theta, this is 90 minus that angle theta. So in math, we would say tangent and cotangents are cofunctions. Based on the angle, whether the angle we're given or 90 minus that, we can express things as the same ratio. So that's one of three cofunctions. The textbook basically makes you memorize them, but that's kind of the play right there. That's the proof, at least, where it comes from. So I hope that helps, buddy. Give that a shot. But really, like to solve these now, that's the concept. We just write the opposite cotangent, and that's going to be 90 minus 67, right? But that's where that comes from because this is already a 90-degree angle in a 180 triangle, so we can eliminate that. That means we have 90 degrees left to play with. We subtract 90 from our known angle, and that gives us our cofunction angle. Hope that helps. If not, let me know.